Time for your applications or your word problems. I'm pretty sure this is going to take me, with all my pauses and stuff, probably an hour and a half to pull this off. I do have some distractions, like there's a hockey game on in my living room, and I'm definitely gonna have a nice big bowl of Death by Chocolate ice cream when I'm done, so I'm pretty focused on that. But let's attack these word problems. You're going to have to ask me a ton of questions if you don't understand what I'm talking about, and you're going to have to bear with some pretty bad diagrams. They don't have to be perfect. The graphs or sketches will be better than the actual pictures. So, for instance, let's see what's going on in this question. So it says a Ferris wheel has a radius of 6 meters and rotates once every 10 seconds. If the bottom of the wheel is 1 meter above the ground, write an equation to represent a person's height above the ground, and also draw a graph / sketch showing one cycle. So you can do more than one cycle. The thing about math, and I hope somebody has told you this before today, you do not have to do the questions in order. So if you feel like drawing the graph first and then doing the equation after, that's totally okay. I personally am going to do the equation first with a doodle, then I'm going to take the doodle and I'm going to turn it into a full-scale pretty graph. So here's my picture. Again, so sorry. So it says a Ferris wheel. So here's my Ferris wheel. Fantastic. And the Ferris wheel has a radius of 6. That means from the center to the outside is 6 meters. Now, I could have drawn that anywhere. I could have done it some diagonal. I could have done it straight out. In either direction. I could have done it down. I'm actually going to put another one down, and that's another 6 meters. In any direction, it's 6 meters. Now what I'm going to do is I'm going to leave it like this. I actually prefer this diagonal, which is 2 radii, to any of the other ones that I could possibly do. Then it says if the bottom of the wheel, so here's the bottom of the wheel is 1 meter above the ground. That means maybe there's a little platform here, so that people can step onto the Ferris wheel, but not to scale. This is my terrible picture. This distance here is 1 meter. Now you don't have to be as detailed as me. Maybe all you want to do is 6 here, 1 there, and forget the platform. Either way, that is a picture that I'm going to refer to. Now remember, I'm going to do a doodle of the graph and then do the real thing. So one of the pieces of information I'm going to write down for you is that if anybody ever tells you the radius of a circle, assuming that you have a circle, and a lot of these questions are because circles repeat themselves. If you're sitting here, you're going to go up and then back down again, and then up and then back down again. So you will have a sine or cos curve. But if anybody ever gives you the radius, that's the same thing as the amplitude. So that's a piece of information that you can hang onto. So in this question, I know that my amplitude, and let me change back into a different color, my amplitude is 6. Now I'm not sure if that means that when I put this into the equation, if it's a positive 6 or a negative 6, that will be determined. So I am assuming, and I hope that this is a correct assumption, but I'm assuming that when I ride a Ferris wheel, I don't get on at the top, at least in this Ferris wheel, or on the side. I get on right here, because that's where the platform is. And then this seat will rotate up and then down again, and then up and then down again. So at this point right here, the minimum place that you are sitting in respect to the Earth is 1 meter above the Earth. Now, you don't actually need the meters, but it is true that the minimum is 1. Now another thing we can figure out is actually the maximum. So when the seat rotates up to here, you can figure out the maximum. And the maximum, I'm going to doodle and then undoodle, is 1 plus 6 plus 6. So my maximum is 13 meters. So if the minimum is 1 and the maximum is 13, you should be able to find the middle. You should be able to figure out how far it is halfway between 1 and 13. Now if you think back to your grade 10 math class, and some of you were stuck with me, in order to find the middle, you take the maximum and minimum, add them together, and divide by 2. So if I show all my work, that's 14 divided by 2, so the middle is 7. And the middle is actually the line of equilibrium, or the vertical displacement. So now I have one piece of information, two pieces of information for my equation. Now I'm going to draw a little doodle of this. So first thing I want you to be aware of with the doodle is that we don't really need any negatives, because then this Ferris wheel is going to be crashing into the earth. We figured out that the minimum is 1 and the maximum is 13 and the middle is 7. So even though it's a doodle, I have this handy dandy line maker, so I can do this. And it's really quite nice that that's beside the vertical displacement. Now what's happening with this particular picture, and I'm going to do this in a slightly different color, is the ride is starting for us at the bottom, and we're coming up and eventually getting to the 13 mark, and then coming down and finishing. And we should be able to figure out, based on the words in the problem, how long that takes. So that takes 10 seconds. So I can put a little 10 here. And I don't need to put a 10 pi, I just need to put a 10, representing 10 seconds. So now I can actually figure out the k value for my equation. So I've got an amplitude, which is the a, maybe positive, maybe negative. I've got a vertical displacement, I know it's positive. I don't have to worry about phase shift, and the reason is because my curve starts right up against the y-axis, which I haven't labeled because it's a doodle. But here's how you can figure out the k value. So I'm going to point to the 10. The period, one wavelength, is equal to 10. I know that there's a little formula for period. That little formula is 2 pi over k. So I'm going to take 2 pi over k and equal it to 10. I'm going to put that 10 over 1 so I can do a little cross multiplying. So I'm going to do this direction first, so that's 10k on one side of the equal sign, and I'll cross in this direction second, which gives me 2 pi. And I need to get the k by itself so I can fit it into the formula, so I'm going to divide both sides by 10. And I know every math teacher on the face of the earth tells you that you have to reduce all your fractions, but I'm leaving my k as 2 pi over 10. Now if you want to, you can divide by 2 on both levels and get pi over 5, but I don't think this is horribly useful, because what I do want you to know is that if somebody gives you how long something is taking for a wavelength, you can just dump it into the bottom. That's a quick little fix instead of going through all this work. And if you can see this, you can see the 10 that is indicating what your period is. So I think there's less of a point to actually reducing your fraction in this particular case. It gives you less information more obviously. So now I can make my equation. Before I make the equation, I want to take a little bit of an aside, and I'll do it here. I don't know how much space I'll take. But I want you to realize that there are Actually, 4 graphs. I know I've told you that there's actually 2, a sine and a cos. I kind of lied to you. Let me just fix this. So, I'm going to put the curve in purple. You have a curve that looks like this. And I hope you recognize that that is the sine curve when your A is positive. You also have a curve that looks like this. And that is the sine curve when it's negative, meaning that if I take away the axis, you start at the middle, you go up first, down second for this one. You start at the middle, you go down first, up second for this one. Now let's look at the other two. The cos graph starts at its high point, goes to its low point, and returns to its high point. So without the axes, it looks like that. And then the last one I want to look at is the cos negative, and I've got a little memory aid for this. Cos negative starts at the low point, goes higher, and then comes back down to the low point. And I do want you to see, and I really like this, I made this up myself, that negative cos is a little ghost, and I like that. I'm going to leave my picture like that. So what you can do is you can try to figure out, based on your doodle or based on the characteristics, if you can picture things, which picture is ours or which picture is closest to ours. And I look at it and I see that it's a negative cos curve. So what I can do when I put this back to normal size is I can say my answer is y equals negative cos, and then I can go looking for my amplitude, which I have a circle around, so it's 6, and now I know that it's a negative 6 as an A value. Then the next thing that comes along is the K value, so I can put that in. I've decided that there's no phase shift. Oops, typo. Combination of two pieces of information. I've decided there's no phase shift because it's sitting exactly where a negative cos curve is supposed to. And the vertical displacement was 7. Now, I want you to know that this is not the correct answer, because in order to graph any of these or sketch any of these, you need an x and a y. So here's my y. I could put an x here if I wanted to. I could put a t here. I could put whatever letter I wanted to represent whatever it is that we're talking about. And in this one, because we were given 10 seconds, I could put a T, but I'm going to stay as simple and as consistent as possible and put an X. So what I now need to do is I now need to take this little doodle right here, and I need to replicate it here, but neater. So I'm going to take a little break. I'm going to cut and paste this so I'm not flopping back and forth between slides, and then we'll talk about how to actually graph a detailed picture. So bear with me while I take my pause. So there's the doodle. I'm going to take that doodle, erase it eventually, but right now I'm going to use it to make myself a real live picture. Now you can use whatever scale you want to. I know I could go by 2s. I'm going to make sure I have 13 boxes because I'm pretty sure I can fit it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, I'm good. Now I know I'm too messy to actually put 1, 2, 3, etc. So I'm going to put 2 here, 4, 6, 8, 10, 12, 14, and this is my y-axis. And if I take a look at the original question, that was in meters. So I do have to designate a unit for word problems. Then it actually asked me to only graph one cycle. So that means I only need to get up to the 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's my 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just in case I want to impress you, this is the x-axis, and that was in seconds. Very popular. So, I like my line of equilibrium, so I'm going to put it through 7 to make this a pretty picture. It helps me keep my bumps the same size, as in my upper bump and my lower bump. Gives me kind of a little guideline. I know that I have to start this picture, let's do it in red, at 1, and then 10 seconds later I return to 1. So the question is, how am I going to space this out? And the answer is the same way as we always do. If we know the period, which is 10, in this case 10 boxes, if I take 10 and divide it by 4, that's 2.5. So every 2.5 boxes, I get to put a dot. So 2.5 boxes, I'm at my line of equilibrium. A half and 2 more boxes, I'm up at the 13. 2.5 boxes later, I'm back here. 2.5 boxes later, I'm at the 10. And then I can draw my picture, and it's perfectly spaced. Just for fun, I'm going to continue to go to there. So no obligation to do that, because when I connect that first dot through this many of them, I am done one cycle. So when I decide to do more, that's okay, because I've done at least what's asked of me and maybe a little more. So we get that picture. Now that looks sort of like the M graph from the first unit. It's not, it's trig. So this is the pretty picture of the graph we doodled to help us through question 1. So I'm actually going to leave this here so you can see that. And we're going to move on to the second question. I'm going to take a little break because I need to hydrate. Here's your second question. So somewhere in here I might take a little dishwashing break. That was a complete aside. Another thing I will probably have to do is continually refer back to my little cheat box. So here's another question, and as long as your word problems represent some sort of cyclical or periodic motion, you are allowed to use sine and cosine curves. If you want to Google what the tan curve looks like and what y equals cosecant x or y equals secant x or y equals cotangent x looks like, all 4 of those graphs exist, and they're ugly, which means they don't replicate things in real life. They don't model real life situations as well as the sine curve and the cosine curve. They are all periodic, meaning they all repeat themselves, but they don't repeat themselves as ideally as these 2 graphs do. And as I've said off the top, the sine and the cosine curve are exactly the same curve moved over from each other. So at some point, maybe in the next question, I am going to generate a second equation that's a little more complicated than the first one, so you can see that there's actually more than one answer for every question. There's unlimited. So here's our second question. In this one, it's a roller coaster. So we're going to go up and down and up and down and up and down. So we're repeating our motion. In Canada's Wonderland, there is a roller coaster that is a continuous series of identical hills that are 18 meters high from the ground. The platform to get on the ride is on the top of the first hill. So the first thing you do, you climb in, you go downhill. It takes 3 seconds for the coaster to reach the bottom of the hill that is 2 meters off the ground. In any order, you can sketch a graph which expresses the path of the roller coaster. And the second question, which you can do in any order, is what is the sinusoidal, so that means the sine curve or the cos curve equation, that best reflects this coaster's motion. So I'm going to do quite possibly 2 of them. But for this question, I am going to start my little doodle. So only positives. We are 18 meters off the ground at its highest point, and at its lowest point, the bottom of the hill, we're 2 meters off the ground. Now this does not tell me the amplitude, it just tells me the maximum and the minimum. But from the last question, we can find the middle pretty easily, which means we can find the vertical displacement pretty easily by taking those 2 numbers, the top and the bottom, adding them together and dividing by 2. So the middle is 10. And once you find the middle, you should be able to find the amplitude by looking at your little doodle. So 10 minus 2 is 8, or 18 minus 10 is 8. They both should be the same. Another way to find amplitude is instead of adding the top and the bottom together, it's subtracting them and dividing by 2. So that gives you 16 divided by 2, which is 8. So you have 2 ways to get the amplitude. Well, actually 3. But I like doing both of these to double check that I'm doing it right. So I'm going to put a circle around this so I don't have to look very far for that information. And I'm going to put vertical displacement and a circle around this. So apparently I start this ride at the 18 meter off the top or off the ground mark, and then because it's a series of hills, I'm going to draw one of the hills on the roller coaster, and I need to figure out that mark. So it takes 3 seconds for the coaster to reach the bottom of the hill. So to get from the top to the bottom, that's 3 seconds, so I'm tricking you. So that makes the period 6. Now there's 2 ways you can figure out your K value. There's the little trickster method, and there's the mathematical method. So the mathematical method, actually let's do the trickster method first. The K value will be 2 pi over the period, which is 6. The end. Now if you wanted to, you could insert the math, which is 2 pi over K is the calculation for period. We're getting 6 over 1, cross in one direction, cross in the other direction, isolate the K, and get the exact same K value. So I'm just going to make this a little bit tinier because I have that magical smartboard ability. And then I will make the equation. There. I don't know why that did what it did. All right, so y equals some kind of 8 sine or cos 2 pi over 6. This starts perfectly up against the y-axis, so I don't have to worry about a phase shift. So I'm going to throw in an x, and then my vertical displacement is 10. So what we have to do is we have to figure out if this is a positive or negative sine or cos curve. So I'm going to refer back to my doodles. And that reminds me of this one. So that means it's a positive cosine curve. So I'm going to leave the space instead of putting a positive sign in, and I'm going to do that. So I'm going to take a little break. This time I'm going to cut and paste the picture, and I'm going to cut and paste this because I want to show you how to come up with another one or two equations. So bear with me while I do that. You don't have to witness this. Okay, it is time. So I don't know if I've got 18 boxes, but I'm getting a little tired. So I'm going to make this 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. This is y. And to refer back to the question, this was in meters and eventually seconds. So this one I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So that would be 3 cycles because 6 seconds was 1 cycle. There is no instruction, I think. No, it doesn't say how much of a graph you need in this case, so I can do as much or as little. I would recommend 1 cycle. So we know that the vertical displacement is 10. Oh, in this picture, I didn't draw the green line. In my real neat picture, I am going to draw the green dashed line to help me out because I do want to be neat. Dig out my good old red pen, start at 18, and end at 18, but at the 6 mark. So then, like I said before, you can take 6, which is the period, divide it by 4, and get 1.5. So every 1.5 seconds, I get to put another dot. So 1 is 1, 1.5, half and a 1, 1.5, half and a 1 lands where I'm supposed to. And because I feel like impressing you with my ability to put down dots, I'm going to do a little bit more. Okay, I'm done. And then I can draw the picture, which we've already discussed is not a ghost. It's an upside down ghost. It's a ghost standing on its head. So this is the positive cos curve. And although I said it was going to be pretty, it's not the prettiest curve I've ever drawn. So here's the thing that you need to know to draw more curves, or to describe more curves, sorry. There is only one drawing. So with this, if you consider this your starting spot, then hopefully, using the little box of information I gave you on that first slide, you can see whether a curve is a positive cos, a negative cos, a positive sine, or a negative sine, and then go and proceed regularly. The thing is, not every person likes to start up against the y-axis like I do. So some of you might be completely allergic to cosine curves. Maybe you just don't see them as well as you can see sine curves. Maybe you see sine curves way better. And maybe you see this sine curve which is the equivalent of a negative sine curve. So there's another starting spot other than the top point. And if you see this curve, you have a different equation. It's just as right. There's nothing wrong with it, but it's different. So what we have to do with this one is we have to say, okay, this is a negative sine curve. I still have the exact same wavelength or period. I still have the exact same line of equilibrium, but this time it's not right up against the y-axis. It's moved over a little bit, and we have to figure out how far it's moved over and in what direction. So this is in the positive direction, so I can put down a minus sign, and it's moved over 1.5 seconds, so I can put a 1.5 there, and that's a brand new equation. There are unlimited of these, as in somebody else in this classroom or somebody else taking this course might not see the original cosine curve. They might not see the negative sine curve. Maybe their eyes are best trained to see only positive sine curves. And if your eyes are best trained to see that, then you have a different curve. So positive sine curve, same wavelength, will have a right moving phase shift, still up 10. And its right movement is 3, 4, 4.5. And you can do this forever. In fact, there's another positive sine curve that's sitting there, right there. And that is exactly the same as this one, only instead of having minus 4.5 in that bracket, you'll have minus 9, 10.5. So you could do this for days and never run out of curves. So the next question is this one. So another cyclical motion type question. So I am going to take a break and set up for this. Hydration, back stretch. I'm all ready to go. So this question. Sarah is riding her bike home from school one day and picks up a nail in her tire. This is pretty funny because I actually got my 3rd flat tire of the summer last week. The nail hits the ground. On my car. The nail hits the ground every 2 seconds and reaches a maximum height of 48 centimeters. Assume the tire does not deflate, which can happen if you've got really good tires. Use the information above to sketch a diagram. I'm going to doodle first. Write the sinusoidal equation, so that gives you the choice of sine or cosine, that describes the situation in part A, and then we have a third question. How far off the ground is the nail at the 1 minute and 27 second mark? So we'll have to worry about that after the fact. So, doodle time. So here's her tire. And if the nail is here versus here, there's enough information in the question to say that, well, she picks it up off the ground, so that's the 0 meter mark, and the maximum height is 0 centimeters. And the maximum is 48 centimeters. So you should be able to figure out the middle by looking at it or by doing that math. So 48 plus 0 divided by 2 is 48 divided by 2, which is 24 centimeters, and that's our vertical displacement. The amplitude, you can do the 48 minus 0 divided by 2, or you can kind of ballpark it and say, okay, well, if this and this together is 48 and we're going from 0, this is 24 and this is another 24. So the vertical displacement and the amplitude are actually exactly the same values, but that is a complete coincidence. As you can tell from the last two questions, it doesn't always happen that way. It says the nail hits the ground every 2 seconds, so you can take the little shortcut for figuring out the period. So the period is 2 seconds, so the k value is 2 pi over 2. If you require the math, 2 pi over k is equal to 2 over 1, cross cross, 2k equals 2 pi, divide by 2, divide by 2, you get that. Remember that you do have the option of sliding a pi in instead of 2 pi over 2, but then you can't see the period. That would be up to you. I can handle both. So let's doodle a picture. 0, 48, 24, 2 seconds, 4 seconds. Oh, how do I draw the curve? Now, I'm pretending not to know this, but if Sarah is riding her bike and her bike picks up a nail, the nail hits her bike when it's going over it on the ground. So I can do my sine/cos curve, my sinusoidal curve there, and I can doodle another one there. And I can keep doing this over and over and over again. So let's see if we can come up with an equation. So my amplitude is 24. My vertical displacement is 24. I have a sine or cosine curve with a k value of 2 pi over 2. I'll need an x, and because this curve is butted right up against the y-axis, I don't need to worry about a phase shift. I do need to worry about what kind of curve this is. Is it a sine curve or is it a cosine curve? And for me, there it is, my little ghost. So this is a negative cosine curve. So what I'm going to do now, even though that is question, which is it? Question A or question B? Question B. Even though that's question B, I'm going to finish question A and then come back to this to figure out question C. So I'll just label this appropriately, which I haven't done with any other question. I'll come back here after I do my little cut and paste job. Okay, so I drew my axes as well. I have to get up to 48, so I'm going to see if I can go by twos and get there. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. No. So, about 4, 6. Oh, let's try that again. 4. Sleepy Tellus. 4, and 4 more, and 4 more, and 4 more. Oh, I can make this. And you might be able to tell right now why I normally don't put down all the numbers, because I'm not exactly the neatest person on the face of the earth. So why is that? And if I check, it's centimeters. It's a bit of a change. And I can do whatever the heck I want along here. So you can tell that these are a little bit different than drawing sine and cos curves for no reason. You don't have pi's along here. Instead, you have a pi in for your k value. So I don't want this too smushy. So I'm going to make Like, I don't want this to be 2, and then I have to smush a little cosine, negative cosine curve in this much space. I can't do that. So I'm going to make that 2. It's still pretty bad. So 1, 2, 3, 4, 1, 2, 3, 4. And this is x, and that was in seconds. So when I go to doodle this picture, I start at 0, I end at 0. Now, I can take 2 and divide it by 4 to figure out my spacing, which is a half. And because this is 1, I know that my next dot will sit on the vertical displacement line at the half mark for my scale. And then it'll go up to the 48 at 1, and then at 1.5 it'll be back at the vertical displacement line, and then a half later at the 2-second mark it'll be there. And I can continue this mostly because I'm good at patterns. I'm going to stop there. So, and depending on how you choose your scale, your picture will look taller and skinnier, but it'll have the exact same information. All right, there you go. So that's question A. Let's go back and see if we can answer question C. So question C says, how far off the ground is the nail at the 1 minute and 27 second mark? So you need to remember that our x value is all in seconds. So in order for me to answer part C, I have to take x, which is 1 minute and 27 seconds, and I have to turn it into complete seconds. So this is 60 seconds plus 27 seconds is 87 seconds. And that will go in where the x is. So y equals negative 24 cos. I'm going to make that as a pi because it's unimportant at this point, because the 2 over 2 will cancel out, and I want just a little bit less writing. We get that. Now, this is where you have to go back to the degrees to radians, radians to degrees. So if you want your calculator in radians, you can use this information right here. That's just fine in radians. But if you don't think in radians, you have to turn that into degrees. So if you turn this into degrees, you need to remember that I told you that pi is 180. So whatever 180 times 87 is the number of degrees that you'll be using. So I'm going to figure that out using my little calculator. And you'll see me in just a second. I'm going to put it in a bracket and then put the plus 24 at the end. And I'm going to need my calculator anyhow. I'm going to have to move this by hand. So 180 times 87, so 180 degrees is pi, times 87 is that many degrees. 660. So now I can do this part on my calculator, so I can find the cos of 15,660 degrees, and it's absolutely unimportant how many degrees that is. And I'm showing all my work. So there it is still on the calculator, and I'm going to hit the cos button. So I need to find trig and hit the cos button, and I get -1 for that value. then I can do BEDMAS. So negative 24 times negative 1 is 24, plus 24 is equal to 48. So this is actually a very pretty point, and I can say that after 1 minute and 27 seconds, it is 48 centimeters off the ground. So it's not at one of those in-between stages, it's actually at one of our dots, but I don't feel like continuing this for 87 seconds when I'm right here at 4. So if you're able to do this by patterns, that's fine, but you can do this using your calculator, which takes sometimes a little less thought as long as you understand degrees and radians. Dig out my red pen. That is degrees. So let me set up for the next question. And the next question is a science-y question. Or maybe geography, sociology. Depends on where you're at. None of this stuff goes away if you're going to university or college. So give me a sec to set up. I'll be back. Okay, so you know, this was an old test question. In previewing this question while I took my break, there is no need to draw an actual picture, but a doodle might be helpful. In fact, personally, I need the doodle because I'm very visual. I realize that is not the case for everyone, but if I can't figure out where you're getting your answers from, then I can't necessarily give you full marks, because this does take some thought, and you should write down what it is you're doing so I can give you full credit. So this question, like I said, sciencey, maybe biology, maybe population studies and geography, because that does happen. Naturalists find that the populations of some kind of predatory animals vary periodically with time, meaning that they follow this sine or cos pattern. In this case, assume that the population of foxes in a certain forest varies sinusoidally with time. So that is telling you sine or cos curve. Records started being kept at time t equals 0. So that's when we started counting foxes. A minimum number of 200 foxes appeared when t is equal to 2.9 years. The next maximum was 800 foxes, and it occurred at t equals 5.1 years. How many years does the population take to reach its minimum again? Another question is, what is the amplitude of the curve? Calculate the median, middle, vertical displacement number of foxes in this population. Write a sinusoidal function, sine or cosine equation, for the population of foxes in this forest, and then finally predict the number of foxes when t is equal to 10.6 years. So I'm going to need a little room to doodle, and unfortunately you're not going to be able to see the entire question at exactly the same time. Hopefully my memory extends to a point where I will be able to remember what all these questions are so that we can answer them. And maybe we come back and see if we can find answers after the fact. So I'm just moving these out of the way. Oh, that one's stuck. So let me draw a little doodle of what's happening. So we're not going into negative time because they started keeping this population data at t equals 0. So we're doing this. And we don't have any negative foxes, so we do have first quadrant information. No negatives on the y, down here or here. No negatives on the x, here or here. And technically, I shouldn't be talking about x's, I should be talking about t's. So I'm going to circle that in yellow just to draw its attention when I get to the equation making question. So this says that the minimum number of foxes was 200 and the maximum number of foxes was 800. The minimum happened at the 2.9 year mark after the study was being started, and the maximum happened at 5.1. So far, this is the minimum, and this is the maximum. So there's going to be another minimum down here and another maximum down here that we should be able to figure out. There is also going to be, just eyeballing it here, a vertical displacement. And we're going to need all these to answer the equation making question anyhow, even if they're not actual questions. So I'm just trying to move that a little bit, not that it matters. So the first thing I'm going to figure out, because I can, is how many years passes between minimum and maximum. Because if I can figure out that space, this space is exactly the same, and this space is exactly the same, regardless of how good my picture drawing is. So I should be able to put a label here, and I should be able to put a label here. So off to the side here, I'm going to do 5.1 subtract 2.9. And I've got my calculator open still in case I can't do that in my head. 5.1 subtract 2.9 is equal to 2.2. So the space here is 2.2, and the space here is 2.2, and the space here is 2.2. So if I can figure out what 5.1 plus 2.2 is, I should be able to have a little label for here. So that's 7.3, and then 2.2 more is 9.5, in case that matters. I should be able to figure out this line. It's the middle, and I've told you a couple of times before that to figure out the vertical displacement, which is the middle, you take the high point and the low point and add them together and divide by 2. So that's 1,000 divided by 2. So that ends up being 500. So I can put a little label there. And I can eyeball this, or I can do 800 minus 500. Allergies is 300. Double check, 500 minus 200 is 300. And that is the amplitude. So let me just doodle a picture. I don't have that midpoint there to make it look pretty, even though it's a doodle. So let's see how many questions I've answered for this. So first question was, how many years does the population take to reach its minimum again? So the minimum is here, and I have an answer for that, which is 7.3 years. And in all this doodle, I'm willing to look up how you found that. No big deal. Next question, what is the amplitude of the curve? Got that too. Next question. Oh, calculate the median middle number. I have that as well. And write the sinusoidal function. So this one's a bit more difficult. I am going to pull this down a little bit so I have some space. And pull this down just a smidge. And see if we can figure this out. So I might put it in space and then drag it into the position it belongs in. So I know it's going to be y equals. And I know the amplitude is 300. I just don't know if it's a positive 300 or a negative 300. I also don't know if it's a sine or cosine curve. I don't even have the period k value there. I don't know if there's a phase shift. I only know that there's a vertical displacement of 500. Well, I'm not doing very good right now. So we have to decide what this is a picture of. Here's my little ghost. Negative cos curve. Where should I put this? The period, which I will drag down, is from low point to low point, or high point to high point, or a midpoint to the alternating midpoint. So I'm going to go from here to here. So that's 2.9 to 7.3. So that is the 2.2 here and the 2.2 there, so my period is 4.4. Now you can do all the math that gets you the k value, or you can say k is equal to 2 pi over 4.4. So I'm going to drag this to a place where it belongs. I am going to fill in the math for those of you who want to do 2 pi over k is equal to 4.4 over 1, cross multiply, get the k by itself, and bam, we have our answer. And that 2 pi over 4.4, or 1 pi over 2.2, is going to sit right here. And I distinctly remember circling a t, so this is a t question, not an x question. The thing is, my little ghost guy is not bumped up against the y-axis. It's moved over some. And we have to figure out how far it's moved over and in what direction, because this picture has a phase shift. So I need a bracket, I need a negative because it's moved right, and it's moved right to the 2.9 year mark. So this little purple blurb is something I got to glue together. And that is my equation. All the pieces can be found somewhere on this sheet. And then last of all, predict the number of foxes when t is equal to 10.6 years. So here's the thing you have to get over. When it says predict, it doesn't mean just guess. It means take this formula and use it to predict the number of foxes. So you have to actually put it in there, as in put the 10.6 in for the t, and gear this out the same way as we did the question with Sarah and the nail. So that little box of information, I'm going to do this in black. No, I'm going to do it in red because I've got the thin red. So y equals negative 300 cos 2 pi over 4.4. T is 10.6 minus 2.9 plus 500. Now I'm going to show all my work. So one of the things I have to figure out is 10.6 minus 2.9. 10.6 minus 2.9 is equal to 7.7. Then I'm going to go rogue a little bit. I'm going to take this, which is radians, and off to the side, I'm going to turn it into degrees. So 2 pi over 4.4 times 7.7, and our conversion factor is either turning pi just straight into 180, because that's what it is, or timesing by the actual conversion factor, which is that. And the reason I say you can just turn pi into 180 is those are going to disappear and you gain a 180 anyhow. So this is something I need to do on my calculator so I don't screw up. 2 divided by 4.4 times the 7.7 times the 180 is 630. So I have turned it into that box of radians into something I'm a little more comfortable with, which is 630. Now you could punch all this into your calculator if you wanted to. So if you took the calculator out, I'm going to move it over for a little bit so you can see what I'm going to do. Once you get it to that point, it's quite easy. You just put 630 into your calculator and hit cos, or the other way around. There's your answer. Then you can times it by the 300 with the negative sign out front. And then you can follow BEDMAS finally and add 500 and get an answer of 500 foxes. The other option is that you show all your work. Your choice. 630. Hit the cos button. I get 0. So this quantity right here is 0. And 0 times negative 300 is 0. Added on to the 500 is 500. So there will likely be 500 B. I make myself laugh sometimes. 500 foxes. So this is if this model works, as in if this formula works and there isn't some massive fox disease that wipes out a bunch, or maybe there are a lot of baby foxes one year and doesn't take the population out of whack. So this is why we call that a prediction using the formula. And as you can see, there was no need to do any graphing. I did a doodle. So next question. My prediction is off, actually. I think I'll be done well before 10 o'clock, which was kind of my cutoff. So here's the next one. I'm going to take a little break to stretch my hand, and I'll be back. Okay, my time's off. I had a back cramp. Here we go. Susie pedals her bike at a constant rate. Oh, I've lost my pen. Such that, so that means so that, the height of her foot above the ground is given by the formula h instead of y. So h equals 12 sine 2 pi bracket t minus a quarter plus 17. H is the height of her foot in centimeters. Just going to jot that down because I don't feel like reading later on. H is the height in centimeters, and time is in seconds. So it says, what is the height of her foot at t equals 0 seconds? Let's keep to blue. It's a new color. So that means I'm giving you the t value, and I can put 0 right in there. So this is quite a lot like part of the last question, the prediction part. So remember, this is in radians. So we have 2 pi times negative a quarter. And 2 times a quarter is a half. Now, I recommend that you know what negative or pi over 2 is, so that means you should know what negative pi over 2 is. And if you don't, that's okay, because you do have the ability to take this radian and convert it. So again, you can either times by 180 over pi, or you can turn your pi just into 180 because the pi's would cancel and you'd end up with negative 90. So h is equal to 12 sine negative 90 plus 17. And I'm going to punch this one all in. So I'm not going to show all my work. So I'm going to put negative 90 into my calculator. So I have to put the degrees in first. Then I have to hit the trig. So some of you are going to have a backwards button pushes. So this part right here is negative 1. All of that. You've taken care of that. We have to take negative 1 and multiply it by the 12 out front because multiplying comes next in BEDMAS. There's the answer to that part, and then we add the 17. So our overall answer is h equals 5. But I need a therefore statement, and I was very smart. Don't know if you know that. What is the height of her foot? Not as smart as I thought I was. Her foot is 5 centimeters off the ground. Look at my handwriting. It's almost time to go to bed. Okay, so now there is a couple of questions that you can answer quite easily if you've been paying attention to what I've said and remembered it. So first thing is, and I'm just going to circle some stuff, I told you that amplitude and radius are exactly the same thing, so I can tell you that the radius is 12 centimeters without hardly doing any work at all. If it had asked me for the diameter, I would take 12 and double it and end up with 24. So I could give you a little bit of a trick question. The other thing I asked you to do is pay attention to the K value. And I'm going to do this in purple, I think. Yeah. So I told you that if you had 2 pi over K, the period, which is one rotation, is sitting right there. And the number that's sitting right there is a 1. So how much time does it take for her foot to make one rotation? 1 second. And those are easy questions. Easy if you know what's going on and can hold all these thoughts in your head. So I realize that that might be a bit of an understatement. So I'm just going to move those so you can see them, even though I'm not saving this document. And we've got one last question. So I want to tell you that this is a very bad question and something that I wouldn't do to you on a test or a quiz or an exam question. It's not very nice, and we'll get into why. I'm going to find all the details so that I can talk about an expression or an equation for the water depth. It's also, before I forget, as I notice it, there's a T in there instead of an X. So I'm going to do my little doodle again, and I'll show you what the problem is and why I don't really like this question. But I keep it in there for 2 reasons: to show you that I can't count, and to show you what a terrible question looks like. So during high tide, the water depth in an ocean harbor is 20 meters, and during low tide, it's 8 meters. So that means its lowest point is 8 meters, and its highest point is 20 meters. We can figure out the vertical displacement the same way as we always do, so this is not a bad question so far. We can take (20 plus 8 divided by 2), so 28 divided by 2, 14, and we have a vertical displacement. No big deal. If we want to, we can do The amplitude is 20 minus 8 divided by 2, which is 12 divided by 2, so 6. And that makes sense because 20 minus 14 is 6 and 14 minus 8 is 6, so that all checks out. So far so good. The tide cycle is 12 hours. It says that right here. So first of all, bad question because you may not know what a tide cycle is. So a tide cycle, for the purposes of this, I think, because it's been a really long time due to COVID that I've been to a beach, tide cycle means that between high tide and low tide is 12 hours. So high tide and low tide isn't one wavelength, it's half a wavelength, so that means the period is 24. So I have to make sure that my questions are detailed in a way that everybody knows what the meanings are. Now, if you use 12, I could totally understand that, and I wouldn't have a problem. What that means is that I can say that K is 2 pi over 24. So I've got a vertical displacement, I've got an amplitude, I've got a K value. Here's the problem. I don't know how to draw my doodle, and if I don't know how to draw my doodle, I can't write the expression and I can't sketch the graph. And the reason is because I haven't told you whether the picture starts at high tide, whether it starts at low tide, whether it starts at the vertical displacement. I have no idea. So you can't draw the picture. If we go back through all the questions, I at least give you hints about where to start the picture. I mean, if you're riding a Ferris wheel, you have to get on at the bottom. You can't get on at the top. That's not where the platform is. This question was super specific. It said the platform to get on the ride is at the top of the first hill. There was no doubt about what was happening. In this one, it is implied that the nail goes into the bike tire when the nail and the tire meet on the ground. This one, it was a bit off, but I gave you enough information to start the curve. This one didn't matter because I gave you the equation. And this one's awful. It just doesn't give you enough detail. So I bring this question up because I have to be careful as a teacher to plan my questions so they're understandable from a student perspective. So I'm going to leave it here, and if you go to the Google site, you should be able to find some questions. I think the best place to start is the supplemental sheet in the booklet, the little tiny trig booklet I gave you. And the next place to go would be any of the old tests that I've put online. And the third place to go would be some questions, and I've also included some challenge questions. So that's where we're at, and I am 10 minutes early. So yay me, but unfortunately, it's an hour and a quarter of word problems. So there you go. See you in the next unit.